Can you talk about, first of all, why we haven't really gotten a look at the solar poles up until this point?
Yeah, so back in the 1990s, there was a mission that was launched called Ulysses. Ulysses traveled and looked at the sun from different latitudes. So usually we've always focused on the sun from the equator perspective. This one kind of flew higher up, so it got us different perspectives. The issue, though, is that this mission was not taking images. It was just measuring basically the flow of particles that was hitting it at those locations. And it already showed us that the poles were behaving a bit differently than other regions of the sun. We have this stream of particles and plasma that's ejected by the sun. That's called solar wind. And the speeds that were measured for the poles were different, which was really eye-opening. But we still don't know what it looks like. And it's been a big question in terms of if we could get a view of the poles, we might get a better understanding of some of the phenomena happening there.
So enter AI, right? Which
Yes.
is in everybody's world these days. Tell me about that process and how you're using AI to get a better look at the poles.
Yeah, so AI is an interesting tool in terms of trying to get a perspective of the poles. A solution to look at the poles would be to launch missions, of course, and satellites. But getting out of this basically equator perspective is not easy. It's not that we can't do it. We could, but from a technological perspective, it'd still be a bit of a challenge. You need to require on a lot of propulsion for your satellites, as well as gravity assist from other planets. So it's a whole process. There's a mission, Solar Orbiter, that's been launched a few years ago that's going to look higher up. It's not going to look down on the poles, but it's going to get a different perspective than what we have. So not just a equator view, but really like a slight view of what we could see at the poles. But it's still a few years away until we get that perspective. And so we decided to turn to AI to try to do this. And the idea is we use a counter method that takes images, so 2D images of an object from different angles, and we'll try to recreate a 3D model out of it. So it's been used a lot, for example, to make models of people. But of course, the sun is not a person. It's a lot more complex in terms of the physics involved. And so this was kind of the challenge, trying to use artificial intelligence that's been used in a different context and try to adapt it to the physical reality of the sun so that can then produce kind of an educated guess of what the poles might look like.
Did it work? What was the result?
Yes. So in terms of results, it's hard to say if it worked or not. We are producing images of the poles. Yeah. But until we get an actual satellite like Solar Orbiter giving us a perspective of what the poles might look like, we can't really confirm what we have. So this is really meant to be an educated guess of what we could expect there to be. And hopefully we can extract some information out of this that could be maybe validated in the future once we have observations of the poles, or at least that could be used to help inform future missions in terms of what they could expect once they reach those locations.
So what are the poles like based on what you've kind of come up with image-wise here? Do they behave like anywhere similar to Earth's poles? Was there anything about it that surprised you?
It's definitely different than Earth. That is for sure. The sun and the Earth, although they have some similarities in terms of both having magnetic fields, they're still very different in terms of properties. The sun has features that we call coronal holes. And if you look at the sun in extreme ultraviolet light, which is where you see most of its activity, you'll see that the poles has two dark regions, basically. Each pole has like what we call a polar coronal hole. And the idea is basically we can see the outlines of those features using satellite images from the equator, but you barely see them. You don't see much. But here now we can really go see in detail that those polar coronal holes and try to extract information out about them. For example, what's their area, what's their outline, and try to relate that to maybe other physical phenomena like the sun's magnetic field potentially, and the stream of particles, the solar wind that is coming out of the poles. So we do get a perspective. In terms of, is it different than what we anticipated? It's hard to say because, again, there's no observations available to really double check if what we're doing is valid, at least not for the next few years.
Will understanding what the poles look like help understand the influence that the sun has on the Earth? Like, there's been a lot of buzz lately about like solar storms and the power grid and flares. So is the end goal kind of like to forecast those events?
So with these kinds of models at the moment, we might gain a better understanding of the sun's interaction with Earth, but it shouldn't be considered a forecasting tool, at least not yet. Really, the way the tool works is it takes observations that exist in a time period, and will try to reconstruct a 3D model of the sun and the poles during that time period. Anything beyond that is a bit more questionable, because it no longer relies on observations at that point. Having this new knowledge of the poles will allow us basically to relate it to some of the theories that we might have. We know that the poles are playing a role in the sun's magnetic activity, which is what creates the solar flares, coronal mass ejections, geomagnetic storms that can impact Earth and have impacts, for example, on our satellites, power grids, communications, all those things. So this is basically, with this tool, we will get a new perspective of the poles and maybe help us assess what the role it plays in these events. But I wouldn't consider it yet a forecasting tools for this.
What's your background? Are you like heliophysicist, or are you like AI computer programmer? What's your expertise?
My background is a solar physicist, but I've been picking up artificial intelligence on the way because I do think it's a neat tool that provides us a different perspective in terms of the data or the theory we might have. And so, although it is pretty hard to interpret what it comes up with sometimes, I think having this new perspective is still really enlightening. And this is an example of it where with this project, we're able to create perspectives of the sun like we've never seen before. This is a pretty interesting example of how we can leverage artificial intelligence to assist in science. Being able to generate novel perspectives of our sun using artificial intelligence is beneficial not from just trying to understand the dynamics of the sun or trying to see the impacts on Earth, but it can also help us get a perspective of, say, what the sun looks like from different planets and trying to measure the impact that it has on those other planets. It allows us also to expand to more general astronomy because the sun is the only star in the entire universe that we can actually take a picture of. Otherwise, all stars look like just a few pixels. This, we can actually look at it, see it all in detail, so it is the perfect template in terms of studying other stars. And now that we have this 3D model of it, based on images that were captured by satellites, we can look at it from a completely new perspective and try to relate to other objects that exist in the universe. And so this is basically just, I think, the start of a lot of potential avenues to explore with these kinds of tools. And so yeah, I think it's a very neat way of combining both our physical knowledge of the object as well as existing satellite observations, all in one package by turning to artificial intelligence.
Hey, thank you so much for watching. While you're here, check out some other videos you just may like.